So today we are going over characteristics of quadratics. Are you guys ready? We're going over characteristics of quadratics. Characteristics are like different. I say characteristics, other teachers say key features. I believe Ms. Lopez always describes these as key features of the graph. So characteristics are just different things that teachers or mathematicians use to describe the graph, Joey. Does that make sense? All right. So they are things like these words, the axis of symmetry, the zeros, roots, or we're going to add this. Oh, I might have ruined something later on the worksheet, but zeros roots are a synonym of X-Intercepts, which is actually another thing there. Maximum, minimum, vertex. Later we'll talk about increasing intervals, decreasing intervals, all sorts of different things that you typically find to describe a graph. So in Math 2, we do this for quadratics. I think later we study square root functions, but I could be wrong. In Math 3, we do characteristics for lots and lots and lots of different types of functions and study them a lot. But in Math 2, we don't focus on that a ton, but we definitely do it for quadratics. All right. So we're just going to go ahead and get started, but this is what we're focusing on today is the different types of characteristics that we could find for quadratics. This is kind of an introduction, so today, if you feel a little bit lost, that's okay. It's not something that's necessarily going to be heavily tested. That doesn't mean that you check out today. You try to understand it as best you can, but if you get a little bit frustrated, don't mentally check out. Keep an open mind today. Ask a lot of questions. Try to understand it, but don't feel like you have to be a pro today. Does that make sense? Okay. So I don't want you guys to leave today feeling stressed or feeling like you can't do it or anything like that. Know that today you're going to take in a lot of information and you don't have to be amazing at it. We're just going to get introduced to it and know that when we get into Math 3 is when we're going to get really good at this stuff. Okay? All right. So the standard form of a quadratic equation is, can you recognize it in the bank of answers? X squared plus bx plus c. All right. The shape of a quadratic equation is called a parabola. Please don't pronounce it parabola unless you are joking. You can say parabola if you are joking. Please do not say it if you are being serious. It doesn't kill a baby animal, but I will laugh at you. And then go, oh, bless your heart, when I realize you're being serious. You can say it if you're joking. Parabola is fine if you are cracking a joke, okay?
What if you just like walk around and we ask your question like, isn't the parabola look weird?
If you say that in all seriousness, people will be like, you are a mathematical idiot. Okay, people will judge you. All right. The imaginary line that cuts the parabola in half is called the axis of symmetry. Axis of symmetry, okay. This point right here is called the vertex. When the vertex is the highest point on the graph, we call that a maximum. When the vertex is the lowest point on the graph, we call that a minimum. Maximum, minimum, vertex, okay? Our solutions are called the zeros and roots. But we know that those are also X-intercepts. Actually, these are kind of 7 and 8 are kind of interchangeable. Yeah, this is kind of, I'm going to put the same answer for both. Our solutions are called the zeros and roots. Solutions to the quadratic equation are called zeros and roots. I don't know really which one they were going for there. So we're going to put the same answers for both. Those are all synonyms. I am not going to nitpick which one you call which because they're all synonyms, all right? So really when it comes down to it, a lot of times they will call answers to the quadratic equation roots because you have a square root in the answer. Does that make sense? And then they will call X-intercepts zeros of the graph because it is where the function or where the equation equals 0. Does that make sense? Because the y-coordinate is 0, so they say the function equals 0. So they're like, oh, it's zeros of the graph. And then they'll say zeros and X-intercepts are like the same thing. But they're all different words that mean the exact same thing, so it doesn't really matter which word you use. Okay, so if we look at the problems, we're going to figure out if it has 2 real roots, 1 real root, or no real roots. So if we look at this, how many X-intercepts do you see? 1. And then we're going to go ahead and say what it is. So what is the 0 of this? 3. I'm going to go ahead and just write x equals 3. Now, if they asked for the x-intercept, I would write it like a point, because an intercept is a point. It has an x and a y coordinate, but since they're asking for zeros, I'll just go ahead and say x equals the number, okay? All right, how many roots does this one have? Has 0. So the x-intercept, or the x-axis is right here, and that quadratic is not touching the x-axis. It is completely below it. So for the zeros, I'm going to say none. I'm not going to say NA because NA means not applicable, and it is applicable. You can ask. So I'm not going to say NA because that means you shouldn't even ask the question. I'm just going to say none. Okay. How about this one? How many roots does this one have? 2. Oh. And then what are they? X equals -2 and 0. All right. Let's go ahead and flip the page. All right. You know we got to have some colors in here. All right, the axis of symmetry is, I'm going to make it a dotted line because it's imaginary. It's not actually there. All right, what number is this happening at? 3. Now, this is a vertical line. Does anyone remember how we write the equation of a vertical line? X equals 3. So this is x equals 3. And so for the axis of symmetry, I'm going to write x equals 3. If you were doing a quiz and you wrote axis of symmetry 3, I would mark you down because you only gave me half the answer. Okay? You need to say axis of symmetry x equals 3 because there is such a thing as a sideways parabola. Instead of y equals x squared, it would be x equals y squared. And instead of having a vertical line for the axis of symmetry, it has a horizontal line for the axis of symmetry. And so instead of having an axis of symmetry as like x equals 3, it would have an axis of symmetry as like y equals 3. And so we have to be more specific when we say what our axis of symmetry is. We have to say it's an actual vertical line. All right, what is the vertex? It is 3. Sorry, right 3 down to 3, -2. Okay. Okay. How many zeros are there? 2. And what are they? Okay, x equals 2, x equals 4. Okay. All right, now at this point, we've probably figured out what the domain always is for a quadratic because we did a lot of that yesterday. So can somebody tell me what the domain is always going to be? All real numbers. Or if you're doing the interval notation, it's going to be negative infinity to positive infinity. Okay. For the range, we're going to look at the very bottom of the graph to the very top of the graph. So the very bottom of the graph is what? And the very top of the graph is infinity. So we're going to say the very bottom of the graph is -2, the very top of the graph is infinity. What do I put at the bottom? Bracket, it can equal -2, top is a parenthesis. Or if I do the set notation, what do I say? Perfect. Okay. All right, so it says graph the following quadratic functions by using critical values and or factoring. You need 3 points to graph and you don't necessarily need all the information listed. Goodness gracious, I swear I can read. I swear I can read, you guys. So if you can factor it, then you're gonna factor it to find the zeros of the graph. So remember, zeros are just x-intercepts. So I'm gonna write that on here. So if you can factor it so you can find the x-intercepts. The middle of the two factors is going to be the axis of symmetry. And so symmetry is going to help us graph this because then if we have a point on one side, we can reflect it and graph that same point on the other side, which some of you guys were doing yesterday when you were graphing on Desmos and the table only gave you half the points. Then you were able to reflect them over and graph the other side. Okay, so we're going to do that. If it doesn't factor, find the axis of symmetry with x equals -b/2a. Go ahead and take a color and just circle that. That's going to be a very important formula for us. And the vertex is on the axis of symmetry, so this is actually how we find the x-coordinate of the vertex. Okay, so this is the x-coordinate of the vertex. Okay. If you have the x-coordinate of the vertex, how could you find the y-coordinate of the vertex? Any ideas? If you have the x-coordinate of the vertex, how could you find the y-coordinate of the vertex? Plug it in. Yeah. So once you plug these numbers in, -b/2a, once you have the equation in standard form, you know what the b is because that's the middle number. You know what the a is because that's the first number. You plug them into this little formula and you get an answer for that. You get a single number for that, and then you plug it into the equation and figure out what your y value is. Okay. And then the y-intercept is 0c. We're going to circle that as well. That's another formula we're going to use. Okay. So it says they want us to have at least 3 points to graph our parabola. We're always going to draw our little dotted line for our axis of symmetry. We're going to try to find the x-intercepts by factoring if we can factor. We're going to try to find, if we can't factor, we're always going to find the axis of symmetry and find the vertex. We're going to find the y-intercept, okay? So x-intercepts from factoring, y-intercept, axis of symmetry. We're going to be able to find a few points from that. At least 3 points is our goal, okay? All right, so when it says critical values, that just means some other numbers. If we can't find the x-intercepts, maybe we could do something like plug in 1 or something like that and then reflect it over. So if you can't find an x-intercept easily, then we could always plug in another number into the equation, reflect it over, just plug in something easy. Sound good? Okay. So if we look at this problem, is there something that multiplies to -3 but adds to -2? Yes. What is it? -3 and 1. So if we write this, and they call it the intercept form because it gives us the x-intercepts. If we write this in intercept form, it would be x minus 3, x plus 1. So there's the factored form, which is also the intercept form. So what are the two x-intercepts? X equals 3, x equals -1. So there's 2 points right there. X equals 3, x equals -1. 3, -1. And I'm sorry the graphs, the grids printed a little bit. They printed some extra lines. I don't know why they did that. Okay, 3 and -1. So what I'm going to do now is I'm going to find the middle of those 2 points. They're a distance of 4 apart. So I'm going to find the middle of those, and I'm going to draw my axis of symmetry. So 2 boxes over, that's going to be the middle. All right, so can somebody tell me what is the x-coordinate of my vertex? 1. Okay, so I'm going to have an x value of 1. You guys want to see a fun way of plugging stuff in your calculator? You don't really need to. It's easy to plug in 1 regardless, but I'm going to show you it anyway. Are you guys ready? Okay, so everybody type a 1. Just type a 1 on your screen, 1 like this. 1, okay? And then down here, there's an STO button. STO, stow. So 1 STO stow, it puts a little arrow on your screen, and then go ahead and hit the X button right here. And then press enter. Okay, now press the X button again. STO is at the bottom. STO. Okay, now if you press X again and press enter, you'll get a 1. So what we did is we just stored 1 in for X. This is a tricky way of storing numbers in for letters on your calculator. So now, instead of typing a 1 in and doing 1 squared minus 2 times 1 minus 3, now I can type x squared minus 2x minus 3, and my calculator says, oh, that's -4. So my calculator is going to plug it in for me. It's a nice way, the higher up you get in math, the nicer it is to be able to do that, because it means that it's going to handle negative numbers correctly. It's going to square negatives perfectly. You don't have to worry about putting parentheses in, things like that. It's just a nice trick to be able to store numbers. All right, so if we plug in 1, we get -4. Say it again. Yeah. All right, and then what is our Y-intercept? The Y-intercept is this formula right here. Can you tell what it is? It is -3. It's the number on the end, -3. All right, so the Y-intercept, actually, they gave us space to write it. So let's go ahead and fill in some of these blanks here. So the zeros were 3 and -1. The axis of symmetry was x equals 1. The vertex was 1, -4. The Y-intercept is 0, -3. I'm writing that like a point. 0, -3. Now, we have the axis of symmetry right here, so let's reflect this point over. Okay. Does this graph have a maximum or minimum? Minimum. I'm just going to write min. Okay. I'm going to go ahead and draw the U shape, that parabola shape. Somebody in the back whispers, parabola. Okay. All right, what's the domain? All real numbers. All right, what's the range? Okay, so -4 is the very lowest it can be, and then it goes up forever. Okay, and we graphed at least 5 points. Okay, how do your brains feel? Brains feel good. All right, let's flip the page. Whoop. All right, now with this problem, we have a negative in the very front, which, believe it or not, is a GCF. We cannot currently do the problem, and we can't treat it like a slide divide problem because slide divide method does not work with a GCF. So we actually have to take out the negative before we get started. All right, so take the negative out. And when you take the negative out, what does that leave you with? I have a cat hair in my mask, and it's tickling my nose. Maybe that was a booger tickling my nose. It was a Miss Rice hair. It was a curl going straight up my nose. All right. Whew, here we go. Okay, so we're looking for two numbers that multiply to -5 and add to 4. Okay, so 5 and -1. So x plus 5, x minus 1. Is this focused? I feel like it's just a smidge. Oh, it's a little bit better. Okay. What are the roots? -5 and 1. Okay. -5 and 1. Okay. So our axis of symmetry is okay, so what is our x coordinate of our vertex? -2. So I'm going to do -2. I'm going to store it as x. And then I'm going to type in -x squared minus 4x plus 5. So this is nice because if we had typed in a -2, it would have been kind of hard to plug in. You would have had to do negative of -2 squared minus 4 times -2 plus 5. So this is a little bit easier to plug in if you plug it in this way than if you plug it in that way. Okay, so 9. So -2, 9. Okay. What is our Y-intercept? 5. Okay, so 0, 5. And then we're going to reflect it over to get that symmetry. So the Y-intercept we got just by looking at the number at the end. So if we weren't using a shortcut to get the Y-intercept, you technically get the Y-intercept by plugging 0 in for x. So if I put 0 stored as x and then go back and plug it into this equation, you can see you get a 5. So that's how it works. But basically, it'll just always give you the number on the end. Yeah. Okay, so we've got our 5 points. Do we have a minimum or a maximum? We have a maximum. Okay. What is our domain? real numbers, or, okay, and then our range is a little different this time since this parabola has been flipped upside down. Y is less than or equal to 9, or how do we write it with the other notation? You're close. Yeah, so we always do the bottom first. So negative infinity goes first because that's the bottom. And then 9 goes second because that's the top. So we always go bottom to top. Good, yeah. So we say multiplies to this one, adds to that one.
No, I mean
We factored out the negative in the front. All right, now this one, if we look, we're looking for two numbers that multiply to 7 but add to 4, and is that possible? Not possible. Okay, so what we're going to do with this one, we cannot factor this one, so we're going to find the vertex, and we're going to do it using that formula, which was x equals negative b over 2a. So our b value is 4, so we're going to say negative 4 over 2a. What's our a value? 1. So 2a is 2 times 1, which is 2. And so what is the x-coordinate of our vertex? Negative 2. So if the x-coordinate of the vertex is negative 2, what's the axis of symmetry? Negative 2. Let's go ahead and draw on our axis of symmetry. So I'm going to take negative 2, I'm going to store that as x. And then I've got x squared plus 4x plus 7. Okay, so my y-coordinate is 3. My axis of symmetry is x equals negative 2. So I've got my vertex is negative 2, 3. What is my y-intercept? 7, so there's my y-intercept, the number on the end. Okay, I can reflect that over. Okay, what next number would you guys like to plug in? What's another number you guys think would be good to plug into the calculator? We could plug in negative 3. Yeah, so negative 3 is right here in between the vertex and in between the next point. So let's do, I'm going to type into the calculator negative 3. I'm going to store that for x. And I'm lazy. I don't feel like typing in this equation again. So what I'm going to do is I'm going to go right up here and I'm going to highlight it. And I'm going to press enter. So it's back on my screen again. And I'm going to press enter again. It's going to spit out 4. So what it does, since I stored negative 3 in my calculator, is this time when I pressed enter, it plugged in negative 3 instead of plugging in the last number that I stored. It's plugging in the new number that I stored this time. So I went ahead and I plugged in negative 3. And write another point, negative 3, comma 4. There we go. And then I'll go ahead and reflect that one over the axis of symmetry as well. We got our parabola. Now they said it graph at least 3 points, but getting 5 points was still pretty easy. Three points you could do without a calculator for the most part. To get the 5 points, the calculator made it a little bit easier for us. All right, max or min? Okay. What do we need to do before we start graphing or start factoring the next one? take out the negative. So if I take out the negative, I have x squared, and then what? Okay. So we are looking to see if there's something that multiplies to -2 but adds to +2. Nothing. Okay, so this is not a factoring problem. So we're going to find our vertex and our axis of symmetry. We're going to say x equals -b over 2a. So our b is -2, so we're going to say negative of -2 over. Our a is -1, so we've got 2 times -1, which is -2. So what do we get? -1. Okay, so our vertex has an x-coordinate of -1. What is our axis of symmetry? -1. Okay. So negative x squared minus 2x plus 2. What's our y-coordinate? 3. What's our y-intercept? That's what's 2. Okay, you're just ahead of us. Okay, y-intercept is the number on the end, which is 2. And then we can take that point reflected over, get this one. Okay. And then how could we get another point? Okay. Oh, we already plugged -1 in. -3? I'll go up here and grab my equation. Oh, -1 is the output. Gotcha. Okay. -3, -1, and then we can reflect that over. Okay. Is the vertex a max or a min? Max. Okay.
Find like another point.
Yeah.
Like the -3, where did that come from?
Didn't you tell me the -3?
No.
I told you like 1 or something.
Oh, so what I did, if you have these 3 points, just pick another x value and pick one that's close by. You could literally pick anyone. Like if you wanted to pick 10, you could, but it'd be really far off the graph. Does that make sense? Yeah, like let me show you. 10, plug it in. Whoa, that's way too far off the graph. I shouldn't have picked that one. Okay, let me not do that one. But what's close by? What's an x value that's close by to the ones we already had? We already had 0, -1, -2. So what's an x value that's very close to 0, -1, or -2? -3 is very close. +1 is very close. Doesn't matter what you pick, just pick something close by. Don't pick 10, it's too far away. And you can kind of tell the way that the parabolas grow, right? They grow like this. There's no way you're going to be able to plug in 10 and actually graph it. Does that make sense? So you pick something close by, and there's not a right answer here. Does that make sense? Now you could maybe pick 4. It's probably going to be too big because it's a little bit too far away. Does that make sense? If you've got these two, 1 is probably a good choice. 2, you might be able to graph. Anything further away than that, you're probably not going to be able to graph. It's probably going to be too big. So what you do is, if you have these 3 points, you're going to pick one that's like a distance of 1 away to the left or to the right. Does that make sense? So I'm not picking it, there's not like a magic one that you pick, you just pick something close. Sorry, I didn't explain that. You don't, there's always numbers stored in there. The default stored number is 0. So like, see how you have all these letters on here, A, B, C, D, E, F, G, see all the green? All those are letters that can have something stored. And if you start doing alpha A, it's got 0 stored. Alpha, hold on. Alpha B, 0 stored. Alpha C, 0 stored. They all have 0 stored until you store something over it. So there's no need to try to unstore a number because it always has a number stored and it's going to be 0 until you replace it with something else. Does that make sense? So don't worry about like, oh, I need to clear it because I stored something and now it's got something, and it always is going to have something in there. And if you, like, as soon as you clear your calculator, you know how whenever your calculator messes up, I tell you to do second plus 712? When you do that, it's going to reset your X to be stored as 0. But as soon as you do something, X is going to store something else. So don't worry about your X having something stored in there. It's not going to mess anything up because you always have something stored for your letters. Does that make sense? Okay. It's the reason why teachers have told you don't try to add your like terms on your calculator because your calculator is not adding x's, it's plugging a number in for you. That's why. So your calculator, if you were like, oh, I wonder what 3x plus 5x is, and I'm going to do it on my calculator, your teacher's like, no, your calculator's not doing that. It's plugging a number in for x every time. That's what your calculator does. Okay. All right, can I help with anything else? Any questions about the stuff that we just did? Okay, now the next problem says a bottlenose dolphin jumps out of the water. The path that the dolphin travels can be modeled by this. So if you look at this, what can we tell about the equation based on how it's written? What do you guys know about it? It's going to have a maximum, and how can we tell it's going to have a maximum? Because it's got a negative in the front. So we know that it's going to go like this. Okay? So it says H represents the height of the dolphin. H is normally the Y coordinate, right? And then D represents the horizontal distance. So when they talk about this versus this part right here, that's the height of the dolphin. That's the height of the dolphin. And then this part right here, that's the horizontal distance. So they're talking about like how far over the dolphin was able to jump versus how high the dolphin jumped. Does that make sense? Okay. What is the maximum height that the dolphin was able to reach? How could we figure that out? What are we actually looking for? We're looking for the vertex. Okay, do we know how to find the vertex? Yeah, what do we do? Negative b over 2a. Okay, so let's go ahead and do that. We're going to say x equals negative b over 2a. And what are we going to do for negative b? Negative 2. And then for 2a, we're going to do over 2 times negative 0.2. I normally multiply those together in my head, but that's too much math for me. Okay, so I'm going to do negative 2 divided by 2 times negative 0.2. 5. Oh. 5. Okay. So we have an x-coordinate of 5. What are you guys getting for your y-coordinate? How did I just get? Are you sure you got 9? Okay. Did you guys just get 5 for your y coordinate? Okay. Now, it says, what is the maximum height? So, which coordinate should be the answer? The y coordinate. Okay. What are the units? Does it have units? That's silly. The dolphin reaches 5. 5 UN, we'll say. It looks like I wrote the reaches 5. Oh, Miss Rice. Silly. It looks like I wrote reaches sun, but spelled it with a weird S. Okay. Uh-huh. All right, now it says, how far did the dolphin jump? How could we figure out how far the dolphin jumped? Yeah, the X-Intercepts. Okay, how can we find the X-Intercepts? How do we find X-Intercepts? Starts with an F. Factor! B factor. Okay, so negative 0.2 d squared plus 2d. I'm going to set it equal to 0. And we have to take a GCF out. And the GCF is going to be, we're going to have to take out this coefficient. It's going to be negative 0.2 for the number. And then for the letter, we're going to take out a d. So it's easy for the first term. It's going to leave a d behind, minus. What should we do for the second term? How are we going to figure out what number should go here? Yeah. There we go. Okay. So, right, for this one, we've got d equals 10. What does the d equal for the one in the front? Not 0.2. Not negative 0.2. It equals 0. The one in the front always equals 0. Do we know why the one in the front equals 0? Because it does. Because whenever you're solving these, you always take your factors and you set them equal to 0, right? So the one in the front, if we take negative 0.2d and we set it equal to 0 and we solve it, what are we going to do with that coefficient? We're going to divide by it, right? What is 0 divided by a number? 0. So d equals 0. Does that make sense? Okay. So we got d equals 0, d equals 10. So how far did the dolphin jump? 10. 10 units. 10 some. Okay, so the dolphin reaches 5 units. I'm going to write high. The dolphin jumps 10 units far. Oh, silly dolphin. We don't know how many units that is. It could be 5 inches. Is it a mini dolphin? Is it like a Polly Pocket? Did you guys play with Polly Pockets? Yes. Polly Pockets! I loved me some Polly Pockets. Did you guys have Lisa Frank stickers too? Was that a thing? Girls, we're having a moment. Boys, ignore us. Lisa Frank stickers, was that still?
Wait, the ones that like you, the ones that the stickers that stick and you can like unstick them?
No, Lisa Frank stickers, they were just regular stickers, but they were like very cartoony and they were animals and they were like bright colors.
Oh, yeah.
Yeah. Ooh. All right. It has more things to find, so we're going to make sure that we kind of understand what it's asking for, okay? All right. Let's go ahead and get started. So what do we do first? What do we do first? Try and factor it. So we're going to say what multiplies to 5 but adds to 6. 5 and 1. So we have y equals x plus 5, x plus 1. So what are the zeros? Okay, so we have x equals -5, -1. Okay. So where is the axis of symmetry? Okay. All right, what is the y-coordinate of the vertex? Okay. What's the y-intercept? Okay. Domain and range, we can do those. Those are similar to what we've already done. So what's the domain? Okay. What's the range? So when you do domain and range, I'm writing both answers. You don't have to do both. You stick with one notation. So whichever notation you're comfortable with, that's what you can do. Okay? All right. Now, increasing and decreasing talks about whether or not the graph is going up or down. And a lot of people are like, well, it depends on how you look at it. And we look at it going from left to right because we're Americans. America. Okay? So here's how I do it. I take a stick figure and I put my little stick figure right here. See my little stick figure guy? Okay? Now, if my stick figure guy starts walking, is he walking downhill or uphill? He's walking downhill. So this is decreasing. Does that make sense? Okay. He decreases.
Nice negative. What was the one that was straight down?
So he's decreasing, and he decreases to the vertex, and what was this blue value right here? -3? Okay, he decreases to -3, and then once he hits the -3, he goes whoop, and then he is increasing. Does that make sense? It's -3. No, it's -3. I promise you, because I've taught this for 8 years, sir. You do have it wrong because I've taught this for a long time. All right, so he is decreasing until he hits an x value of -3. That's the y value. This is an x value of -3. You are talking about the y value. I'm talking about the x value. I do like that you guys are correcting me, but I do have a high school diploma and 2 college degrees. Okay, so I have my bachelor's and my master's. I'm a very educated woman. Okay. Yeah, so I said -3 and I meant it. Okay, so -3 is the x value here. Now, a left arrow is a negative infinity, so we're going to write negative infinity right there. A right arrow is a positive infinity, so we're going to write positive infinity right there. Okay, now the word decreasing is written in between the negative infinity and the -3. So the answer for decreasing is negative infinity and -3. Now, the part that confuses students about decreasing and increasing is that with range, we were allowed to have brackets, and with decreasing and increasing, we are not, even though you can clearly see it on the graph. Okay, so here's why we are not allowed to have brackets. Because increasing and decreasing is talking about the slant. Does it slant up or does it slant down? Does that make sense? Does it slant up or does it slant down? If I cover up everything else and just look at -3, do you guys see that little dot? Okay. Does that dot slant up or down? That's why we don't put a bracket around it. Because I can't include that in slanting up or down. It doesn't do either of those things. It is just there. It's just a little dot. Does that make sense? So a bracket says you include it in the answer. That's what a bracket says, included in the answer. I can't tell if that dot slants up and down. Can you tell if that dot slants up and down? I can't put a bracket if I can't include it in the answer. Okay? So I put a parenthesis because it's not included. Okay? We can only put a bracket if we can include it in the answer. Okay? All right, increasing is written in between -3 and infinity. You see that? So we write increasing -3 infinity. Okay. So we put parentheses because if I cover this up, is it slanted up or down?
I mean, if you really looked at it.
It's a dot.
Turn your head.
Is a dot. Is a dot.
There's like a 2, there's like a point.
Is a dot.
1 degree.
Okay, so when the stick figure is right there, is he going downhill or uphill? What's he doing?
Yeah, but then.
Which one is he doing? Which one is he doing? So that's why no bracket, because we don't know which one he's doing, because he's not doing either. He's in between. He's in between. That's why we don't put a bracket there. Okay. Now, positive intervals are up here. These are positive because your y coordinates are positive there. Negative intervals are down here because your y values are negative. Does that make sense? Positives, y values are positive. Negatives, y values are negative. Does that make sense? Y value is positive, y value is negative. Okay? But so they're saying, where are the y values positive? Where are the y values negative? So the x values are the answer. Okay? Which is weird because you're saying, where are the y values positive? They are positive at these x values. Where are the y values negative? They are negative at these x values. Okay? So I'm going to trace it for you. So the y values are negative starting at this x value and going to this x value. Okay, so the negative interval starts at, what's this x value? Okay, now at -5 we have a y value of 0. Is 0 negative? No, okay, so I'm going to put a parenthesis there. And it's negative until -1. At -1, the y value is 0. Is 0 a negative number? No, okay, so I'm just going to put a parenthesis there. Okay. So the ones that I expect that you'll do okay with today are domain and range, and the rest of it, the ones that are probably going to make you like a little bit, are the increasing, decreasing, positive, and negative. Okay, and that's okay if those make you go a little bit. Okay. All right. The other answer we're going to put is the negative infinity. See, I've got that negative infinity to -5. Okay, and then for this other answer, what do we put? -1 to infinity. Whew. Okay, how are your brains? Brains are okay?
Really hanging on.
Yeah, like
About to fall off the deep end.
fall off.
I'm kidding.
I get -1, right?
-1. Well, notice the -1 was the X-intercept. Yeah. But look, what a pretty colorful graph we have. Fine! You don't like my colors? This is purple. It's purple and blue and orange. You want me to choose other colors? I do not know where my green is. Okay. Let's do the next. Actually, let's go ahead and flip through the packet and you tell me which one to do next because there are some other ones that are maybe more difficult. Let's do 8. All right. How do we start number 8? Don't tell me you're afraid of a slide divide. Nate, you want to go to the bathroom right before we start one like this? It's not a slip and slide, it's not a photo math. I will stab you in the face with a chair. Just kidding. Just kidding. I didn't mean it. Just kidding. All right. It's a slide divide. I said no. Nate, you were just like, she meant I could go to the bathroom. Nate, let's get started with this one first. You were like, this one's a more difficult problem. I'm going to peace out and go to the bathroom. All right, this is a slide divide. We don't call it slip and slide. We're in high school now. It's a slide divide. What do? 2 times -3 is -6. Multiplies to -6, adds to -5. All right, so we got x minus 6, x plus 1. But that's not really it. We actually have to divide by 2. So we've got x So what are the X-intercepts? So it's harder to find the vertex, huh? And harder to find the axis of symmetry? How do you guys want to find the vertex and the axis of symmetry? How do you guys want to find the middle?
I'm kidding.
We could just do the formula, negative b over 2a. Do you guys want to do that? Okay. So we've got -5 over what? 2 times a, so 2 times 2, it's just 4. So the x coordinate is positive 5/4. What's 5/4? 1.25. Okay. All right. So just a smidge past 1. is slightly below 6, negative 6. We said, we are not a fan of this. We said, no thank you.
No, not this. I hate this. I like it when it's fun.
What is the, but thank goodness we're doing this one together, yeah? What's the Y-intercept? Negative 3. Reflecting this one is hard because it's like, yeah, I'm not going to reflect this one. To find another point, maybe let's just plug in 2. You guys want to just plug in 2? Okay. Because we're supposed to have 5 points. But how did you find your 5th point? How? Flipped what over? How did you reflect negative 3 over? You just did 1 and some change?
Yeah. I mean, like, it looks the same on the graph. Like, they don't even see it.
I'm going to do 2, negative 5.
Even large on the line, but like, I don't know.
That bothers me. The points aren't like
Symmetrical.
We're not gonna have any more of these decimal things.
I mean, it's not comfortable, but we're handling it.
You're not willing.
All right, what's the domain? Yep. Yes, it is. And you can kind of tell because see how it goes left forever, right forever? All right, what's the range? So the very bottom is this negative 6.125. Ooh, we have to go back to the first one because we forgot to say if it was a max or min. No, it's just a very small thing. Was it a max or a min? Okay. Minimum. Okay. All right. Is this vertex a max or a min? Min. Yeah, notice the range. It's not just negative 6, it's 6.125. Okay, are you guys ready to do the stick figure? Okay, what's your little stick figure guy? What's he doing? He's decreasing, he's going downhill until he hits the blue line. And what is the number of the blue line? Wait, what's the number of the blue line? The blue line. 1.25 or 5/4. It can be your decimal or your fraction, it doesn't matter. 1.25 or 5/4. Okay, and then once he hits the blue line, he starts going uphill, which is increasing. Now, we have to write the number for our arrows. What are the numbers for our arrows? Infinity on the right. What about the left? Negative infinity. Okay, so I wrote the word decreasing between what two numbers? Negative infinity, 1.25. Okay, I wrote the word increasing between what two numbers? Okay. All right, what part do I need to trace to figure out the negative interval? everything under the x-axis. So I start at this x-intercept, which was what? Negative 0.5 or negative 1/2. And I trace it all the way over to what value? 3. So it's negative from negative 1/2 all the way over to 3. Okay? My positive interval is going to start at the left arrow, which is negative infinity. And it's going to go to the first x-intercept, which is negative 1/2. Okay. And then my other answer is going to start at the other x-intercept, which is, and go up to infinity. And they do not have brackets. Can somebody remind me why they do not have brackets? Yeah, because the x-intercepts are 0, and 0 is not considered to be a positive number. It's not considered to be a negative number. It is a neutral number. It's in between. Not positive, not negative. So it's not included in either answer. Okay. Should we do one more with a negative coefficient? Nate, you're good to go to the bathroom. He's like, peace out, I'm done. Do you guys want to do the other slide divide problem so you don't have to do a slide divide at home? Okay, so the other slide divide problem is number 6. And it has a negative coefficient, so it's a good one to do together. Nate, if you had feelings, you didn't have to, like, knock stuff down. Nate was like, I had to go to the bathroom that whole time. All right, so before we get started, we have to take the GCF out, and believe it or not, there is a GCF. Does anyone know what the GCF is? The negative sign. The negative sign is the GCF. We got to take it out. So let's take out the negative sign, and what does that leave us with? All right, and then if we start the slide divide, we got 2 times negative 3. And then, so we're looking for something that multiplies to negative 6 but adds to negative 4. It is not a slide divide.
What?
Ruh-roh.
Find the vertex.
So we're going to find the vertex. So it's not factorable. Yeah, so it's not factorable. I'm going to go ahead and erase this. We're just going to find the vertex and the y-intercept, and then we're just going to maybe plug in an x value or 2 and find some points. Okay, which is, I'm okay with that, because it was going to be a fraction again if it was a slide divide, so this is kind of nice. Okay, so we got negative b over 2a, so negative 4 over what? Negative 4, 1, okay. So our vertex has an x-coordinate of 1. For the formula is x equals, so it will always give you an x-coordinate. So what's the y-coordinate?
Oh, I did something wrong.
Typoed?
Oh, yeah.
Okay, so we got 5. We got axis of symmetry, x equals 1. Ooh. I always know that I'm doing a good job teaching when I start to get the size.
Take it till you make it.
Write it down.
What is the Y-intercept? 3. Okay, so let's practice figuring out what to plug in. So if it has an x value of 0, an x value of 1, and an x value of 2, I don't want to plug in an x value of 10, that's way too big. We could plug in an x value of 3. Okay, so 3 is... I plugged in 3. Did you have a typo? All right, now, hey guys, for any problem that you were not able to factor, when you get the answer none for zeros, for positive and negative intervals, you're going to say skip. Okay? Because if we're not able to find the X-intercepts, we're not going to be able to answer that question. Does that make sense? Okay. Yes. So any problem that don't put none though. Don't put none for zeros. There are zeros, we just don't know what they are. They're decimals. That was me. Don't put none, just put skip. We're skipping them because the problem wasn't factorable. That means we don't have to skip them.
We do have to skip them. No.
I forgot. Sorry. I was thinking in terms of math 3. I was thinking you guys don't know how to find them on the calculator yet. We can't do it. You guys know how to do it. Here's our options. We have all the different ways we've learned how to solve. It's not factorable, so what are the other ways that we've learned how to solve? Square roots. We can't do that because it has a b term, so what are the other ways we've learned how to solve? Quadratic formula or completing the square. Okay, so do you guys want to do quadratic formula or do you want to do completing the square? Okay, so we're going to say 0, we're going to set it equal to 0. 0 equals negative 2x squared plus 4x plus 3. And how do we do the completing the square process? Minus the 3. Is it messing you guys up that I put the 0 over here? Should I put it on the other side? Okay. So we're actually not gonna have to skip these. We're gonna be able to do it. All right, and then what do we do? And then what do we do? Divide not by 4. Look, not 2, -2. So we got x squared, and then what do we have? Minus 2x plus blank. Okay. So we're looking for something that adds to -2. It's got to be the same. -1, -1. And -1 and -1 multiplies to 1. Okay, so 1 is what we're adding on this side. And if we add 1 on that side, what do we have to do on the other side? Okay. So we have x. What do we have? We have x minus 1 squared equals, what is 3 halves plus 1? 5 halves. Okay. We knew the answer was going to be a decimal. We can see it over here, right, that it's a decimal. So we know this answer is not going to be very nice. Okay, so what do we do now? Square root both sides. And what do we do to not kill any horsies? Okay, plus or minus square root 5 halves equals x minus 1. Okay, then what do we do? Add the 1. So plus or minus square root 5 halves plus 1 equals x. Okay. It was a lot of work, but we could do it, right? Those are the zeros. They're decimals. We're about to write them in. What are those? No, okay. Square root 5 halves plus 1. Okay, so here's what we're going to do. See this funky decimal? Oh, we don't need to store it because we already know the y-coordinate is 0. So 2 point, we're going to write this right here.
What?
Oh, because today we have cats. Today is cats. All right. Hey guys, pay attention to I will finish this video, so I will tell you where to watch it. I will finish this problem, okay? And then I think what I'm probably going to have you do is maybe like 2 of these at home tonight. Does that sound reasonable, having to do 2 of these? I will tell you which ones to do. I will look and I'll make sure they're reasonable, okay? Leave your assignments, leave your explorations from yesterday on your desk. All right, so let's go ahead and get this one finished up. So the first x-intercept that we have is the square root of 5 halves plus 1, which is 2.581. I'm going to go ahead and label that. And then we have negative. The negative version, negative square root 5 halves plus 1. So I'm going to get my cursor right there at the beginning and then do second insert and put a little negative right there in the front. Negative 0.581. So it looks like my sketch wasn't too good. My point should have been about right there if I had done a good job. Okay. So I can still go through and do all the information for the rest of this stuff, the increasing, decreasing, positive, negative, all that stuff that I need. So domain, just like all the other problems, was all real numbers or negative infinity to positive infinity. You do not need both of the notations. Commit to one or the other. For the range, We have negative infinity all the way up to the vertex, which had a value of 5, so negative infinity up to 5. Or you could say y is less than 5, less than or equal to 5. So either have these two answers or have those two answers. For this one, when we have our stick figure, again, we always start with the stick figure on the left side. So the stick figure would start over here. And we're still going to say the left arrow is negative infinity and the right arrow is positive infinity. But this time, the stick figure, when he starts walking uphill instead of starting to walk downhill. So he starts by walking uphill. This is an increasing interval. He starts by increasing. He gets up to the top of the hill, which has the blue line, which has the x-coordinate of 1. And then after he gets to the top of the hill, then he starts decreasing and decreases to the infinity. So the word increasing is in between negative infinity and 1. And then the word decreasing is in between 1 and infinity. All right, we have our negative interval is the part that is underneath the x-axis. So that's going to be from negative infinity up to that x-intercept at negative 0.581. So negative infinity to negative 0.581. And then the other negative interval is from the other x-intercept, the 2.581, to positive infinity. And then the positive interval is the part that is above the x-axis, so from negative 0.581 all the way to 2.581. There's the positive interval. All right, and there we are, done with number 6.